Guys, a couple of months ago I did a rigging setup where I needed to lay some tension into a speed line. I thought it would be awfully nice to have a little pocket MA system that could make that quick and easy. I wanted to build one system that would somehow deliver the best benefits of the 3 systems that are out there now. The pocket rescue systems are small, strong, and they seem to jump up out of nowhere to go to work fast. The Fiddle Block systems are perennial favorites for tree work. Their best feature is an excellent rope geometry that cuts friction, and it's that extra efficiency, especially in a hand-drawn system, that lets you get so much done with Fiddle Blocks. And finally, there's the classic set of 4s, or the 2 dual Prusik binding pulleys. They're especially good for tensioning or long hauls, where the rig needs to index and take several strides down the line.
Guys, here's the system that can do all of that. 8 pounds out of the bag, including 90 feet of 10 millimeter HTP. The hardware is all Rock Exotica. As far as I'm concerned, Rock Thompson should be designated a national treasure. They're doing some nice stuff out there. The head end is their P51D, swivel, dual sheave, midline loading, Beckett 36 kilonewton. It's a jewel of a pulley and it's perfect in that application. The tail, the anchor end, is a little more problematic. I did not want to use another dual pulley. I wanted a better rope geometry, less friction, more efficiency for a hand-drawn system. And I wanted space for real performance prusiks, not just a plain Jane rigging prusik. Let's take a look at this arrangement. This uses the Rock P22 pulleys, and let's take a look at this arrangement without the cordage. Guys, I think this is a very clever idea. I would love to take credit for this idea, but it's posted. It's posted on the Rock Exotica website, buried in a PDF file. That PDF file shows you how you can take their P22 pulley and configure it into a variety of complex multi-sheave, multi-Beckett configurations. That's possible for 2 reasons. The pulley is machined, the side is smooth and flush, and there's no axle sticking out to interfere with a carabiner or to try to grab a prusik that is passing by. In addition, Rock has built a little micro rigging plate into the design of the pulley, and that lets you build up a 36 kilonewton rigging system using 2 lightweight aluminum climbing carabiners. The only thing about this configuration that didn't work for me was that the cordage for the top pulley would have to be splayed out and come in at an angle. Otherwise, you'd pile the rope on top of each other and it wouldn't be any good. And the only thing I did was stumble into a very small tweak in the configuration. And bingo! Now the pulleys are at right angles to each other, and the cordage is held at the corners of a square. It's kind of like a Fiddle Block spreads its cordage out in 2 dimensions. This spreads the cordage out in 3 dimensions, and yet still maintains an overall compact size. There's plenty of space for not 1, but 2 prusiks, high-performance prusiks, a control prusik and a load prusik. Let's go back over and see how this builds up into a working system. So here we are back with the cordage. Now let's configure the system for the 5-to-1 MA or the Fiddle Block equivalent system. In order to do that, we want to use only the control prusik and lock out the load prusik. The off button is right here. It's one of the new microbeaners from DMM. All we're going to do is snap it into the carabiner and then onto the HTP above the load prusik. And now you can see that prusik is held out of the system. And since it's a VT and the cordage being what it is, it comes out of the system with virtually no drag residual in the system. The action is very smooth, very efficient. The control Prusik sees the load through a 3-to-1 mechanical advantage, and the action is really sweet. I have climbing systems that aren't this nice. Let's go outside and see some typical rigging configurations for the 5-to-1 MA or the Fiddle Blocks system.
All right, here we've got kind of a classic setup. This might be a pick-off where you need a little mechanical advantage to lift something and then lower it. And this is how you might use the classic Fiddle Blocks. We're going to set up around the porty, and the porty will be available to safety the line, index the system, and if we were going to do any serious lowering, we would use the lowering for that. We're using 3/4 inch 10X as the rigging line, and in that circumstance you almost certainly want to use the porty. In another setup I'm going to show you an alternative to the porty that's a little faster and a little lighter, but not as strong.
So here's the system coming out of the bag, and I've already set a lead Prusik on the line, so we're just going to hook up the system to the lead Prusik, and at the anchor end we're going to make sure both Prusiks are released. All right, we have the load Prusik locked off. Now we're going to release the control Prusik, pull through line, and hook up to the porty. So here we're going to set up the control Prusik again, and now the control Prusik is in the system and the load Prusik is locked off. Okay, with the Prusiks ready to go, we'll just start hauling on the lead end. Now we're working with a 5-to-1. You see the log coming up. No strain, no pain. And I did this on purpose. You'll notice that we're now indexed together. We're at the full travel of the system. So we have to advance the Prusik. How are we going to do that? Well, we do it with the porty. And there's nothing special about this. This is the way the porties and Fiddle Blocks have been used for years and years. What we're going to do is dump the tension off to the porty and pull slack into the system so we can advance the lead Prusik. Now, this works, but it's not as elegant as the hauling system. The MA system will give you about 15 feet of lift before you run out of rope, and then you have to go through this indexing exercise, but you do have the option to set it over to the hauling system. Now here we've indexed out a little bit, and we continue our 5-to-1 advantage. The rope's coming out. And the log is airborne. Okay, and just to demonstrate the smoothness, the control Prusik is behind a 3-to-1 mechanical advantage, and you can control that load very smoothly and very effectively. So let's take it back up again. We have the full weight of the log on the system. Now, this time, we're going to dump the tension into the porty and let it do the let down. Here again, there's nothing new. Fiddle Blocks and porties have been doing this for years. The porty takes on the role of safetying the line, managing a descent, and allowing the blocks to index. So here I'm dumping the tension into the porty and going to disconnect the system and manage the descent through the porty. Pretty basic stuff. When you're working with 3/4 inch rigging line, presumably you're doing that for a reason, and the porty is really the only good option you have in that circumstance. If you're rigging with 1/2 inch line, presumably the loads are lighter, and if you know that the loads are going to be light and predictable, I'll show you another alternative to dragging out the porty.
Here's an expert-only method for rigging the MA configuration. Here's our setup, this time with 1/2 inch stable braid. And when we look into the anchor area, we see the porty is gone. We've taken the normally locked off load prusik and retied it directly to the rigging line, bringing the eyes back to the anchor beaner. This configuration picks up some nice benefits, but it comes at a serious cost. It should be only used by experienced riggers in light and predictable rigging situations. The benefits are pretty obvious. The prusik is faster than the porty for taking in slack on the rigging line. It's way lighter than the porty. If you're rigging midline on a standing line, it's nice to get rid of that weight. If you're rigging vertically, losing the porty will pick up 10 to 12 inches in extending your reach. And finally, this capability is essentially built right into the system. You don't have to go fetch an external piece of hardware to carry out a light rigging task. But here's what you need to know. The prusik is strong, but its bite on the stable braid seriously weakens the rigging line itself. Special thanks to Luke at TreeStuff.com for running this brake test. The stable braid broke before the prusik, which is good, but it broke at 17 to 20 kilonewtons. That's down very substantially for a system built nominally around 36 kilonewton components, and you need to take this into serious account. Operationally, the system lifts the same as before, but the lowering is different. It's more like working with a fiddle block with a cleat on the working end of the line. You're going to be lowering primarily through the mechanical advantage. You can drag the prusik, of course, and the prusik is there full-time for safety, but the descent is managed by your force on the mechanical advantage, not by friction. Let's go back inside and see how the system can flip quickly back and forth between MA and hauling. Okay, so that was the 5-to-1 MA. You saw it working with a porty. You saw it working with the load prusik operating on the working end of an existing 1/2 inch stable braid line. That's by far the most common configuration. But when you need to do long hauls or long tensioning on a line, where you have to index the line multiple times, take several strides through the system, the hauling system does that faster than the MA system. The MA isn't bad, but the hauling system is really fast. So let's convert this to a hauling system. In order to do that, we're going to lock off the second prusik, and here the off switch, which is to simply slide the eye to eye off the nose of the RockO beaner and let that prusik simply run with the system up and down the line. Now, with both prusiks locked out, simply lift the HTP off the becket and pull through as much rigging line as you need for the task at hand. I use this in two ways. I either
use this directly as the rigging line, or I tie this to a rigging line well out so I can stride up the HTP and tension that line as I need to. You turn the load prusik back on, and now this thing will index very quickly. If you need to drag a log up a 70-foot hill, going over to the hauling configuration will save you some time. Before we go back outside, I would like to make one comment here. Most hauling systems or tensioning systems are basically a set of fours, the classic set of fours, 2 dual prusik minding pulleys, and they're sold without rigging line so that they can be installed on the host rigging line and do their work for you on your existing rigging line. If you want to do that with these pulleys, you absolutely can. All the pulleys are midline detachable. You can lift them out of there and reconfigure them directly on your rigging line. Fine. I don't like to do that just because it seems to fly in the face of the basic idea here of having something that's prepackaged and ready to go fast. If I really want to set up a set of fours on my rigging line, I'll go to my pulley box and grab something there, and I'll leave this intact. But strictly up to you. Here's a log we're going to haul. It's about 9 feet by 9 or 10 inches in diameter. We're going to drag it over to an anchor point that is 60 or 65 feet away. With 90 feet of cordage available in the system, we can't run doubled line all that distance. So we're going to set up the hauling system and then take multiple strides down the line, multiple repeats on the hauling system.
So system comes out of the bag, and it was put away in its MA system. So we're going to have to convert that. And we have the load prusik locked off, and we're going to turn the control prusik off, slipping off the eye to eye. So we've got the 2 prusiks turned off, and now we're going to unhook the HTP from the becket and start pulling through rigging line. Since it's a pretty long way away, instead of just walking this out there, I'm going to pull through virtually all the line that I have. So let's just pull the rigging line through. We're going to need about 60 feet of travel. So we'll start with just a modest piece of doubled up rope. Okay, and we're walking to the log. All right, so we're secure on the log, and now we'll just pull the rigging line tight. Put in our lead rigging prusik. Hook the system in. And now the only thing we have to do back here is to turn the load prusik back on. So we're going to take the little DMM microbeener out of the system, and now we should be pretty much ready to go. We'll advance the system and the lead Prusik, and we've got a 4-to-1 haul system. This is what I meant, that the indexing process is faster on the haul system than it is on the MA system. You can do it with the MA, but you have to reset the porty and you have to do a few more steps to dump the tension. But with the haul system, you just have at it. And it's kind of far away, but that log is doing what it's supposed to do. I'm going to index once more. Just grab it and pull. You notice that the lines are staying apart from each other. Very little rope on rope friction. The reason I'm breathing hard is the log, not the rope friction. Going to index one last time. Here's the log. So we've gotten some useful work done, set up pretty fast, and I didn't even have a rigging line with me.
Okay, that's going to do it for today. I would like you to know I'm going to do 2 more videos on this system. I'm going to do one with the build details, the list of components and little things you might want to know if you're going to put it together for yourself. The second is I'm going to discuss another configuration with a different reeving pattern that is particularly good in a low headroom pickoff situation. Everything you've seen today is based on a reeving configuration that is specifically chosen to allow a fast conversion from the MA configuration to the hauling configuration. All you have to do is pluck the HTP off the becket and reset one of the prusiks, and the conversion is done. There's another way to reeve this thing that allows one of the P22 pulleys to actually fold out of the way on the upstroke, and it very substantially reduces the amount of vertical space required. I'll show you that. If you've got an interest in either one of those videos, you should hit the subscribe below and you'll be notified automatically. Thanks for watching.